When doing an acid and base reaction, there's 6 steps that we need to follow. First step is to identify the acid and the base. Then we want to draw out the electron movement, and then with this we can write out the products. After we have the products, we need to identify the conjugate acid and the conjugate base, and then we need to assign the pKa values for the acid and the conjugate acid. Once we have this, we can determine the direction of the reaction. We need to go from a lower pKa value to a higher pKa value. This acid-base reaction is between hydrochloric acid and sodium hydroxide. And first, we need to identify our acid and our base. So we can look at charges to help determine the base. We can see over here, this oxygen has 3 lone pairs, and it's also associated with a sodium. So we usually know that sodium and other metals in the first column have a positive charge. So we can go ahead and put our positive charge here. And if we look at the formal charge here, we can see that it has a -1 charge, so we're going to put a minus here. Now, we can look at the acid over here, and we can see that it has a hydrogen that it's ready to give up. So we can call this our acid, and we can call this our base. So now when we draw our electron flow, we can draw from this lone pair here, which is going to make a new bond with the hydrogen, and the electrons from this bond here are going to go to the chlorine. So now we can draw out our products, which are going to be sodium chloride. Now it's going to have 4 sets of lone pairs and a minus charge. And there's still a positive charge on this sodium here. And our other product is going to be water, which is H. And there's going to be 2 now lone pairs on here. Now we need to identify our conjugate acid and our conjugate base. This is going to be our conjugate base because it doesn't have any hydrogens that it can give up. And this is going to be our conjugate acid. And now we need to assign pKa values. And over here, for the hydrochloric acid, we're going to have -7. And for the water, we're going to have 15.7. So we can see that it goes from -7 to 15.7 from a lower pKa value to a higher pKa value. So this reaction will go to completion. And if you need any more help, refer to your acid and base tutorial sheet. This acid and base reaction is between acetic acid and sodium hydride. And first we need to identify the acid and the base. And if we look here, we can see that the hydride has a minus charge and is associated with the positive charge of sodium. And over here, the acetic acid has a hydrogen that is ready to give up. So we're going to put this with our base, and this is going to be our acid. Now, we need to draw electron flow. And which hydrogen is it going to go to? Is it going to go to the ones on this carbon, or is it going to go to the hydrogen attached to the oxygen? It's going to go to the one attached to the oxygen because it's got a lower pKa value, and it's more acidic. So we're going to draw electron movement. This bond, the electrons in this bond here are going to go to the oxygen. So now we can draw out our products, which are going to be the sodium salt of acetic acid and H2. Now, we need to identify our conjugate acid and our conjugate base. This is going to be our conjugate base because it's ready to accept hydrogens. This is going to be our conjugate acid. Now, we need to identify the pKa values. For acetic acid, this is 4.75. And for hydrogen, it is 35. So now, we can see that it goes from 4.75 to 35. It goes from a lower pKa value to a higher pKa value. So this reaction will go to completion.
Let's take a look at the acid-base reaction between 2-butene and sodium hydroxide. First, we'll need to designate our acids and our bases. In this case, oxygen has a negative charge and 3 lone pairs, which indicates its ability to pick up a hydrogen. Let's designate it as our base. The alkene has hydrogens that it's able to donate, so we're going to designate it as our acid. To show electron flow, we'll draw an arrow from a lone pair to a hydrogen, showing the formation of a new bond. With the formation of a new bond, we must break an old bond, and we'll show the breaking of that bond by drawing an arrow from the bond to the adjacent carbon. The product that is made once the reaction goes is going to be the negatively charged alkene species associated with the positively charged sodium. Also, the hydroxide which bonded with the hydrogen went to form the conjugate acid water, giving this to be our conjugate base. Okay, now we must look at pKa's. The pKa of the alkene is 44. The pKa of water is 15.7. Looking at this, if you go from a higher pKa to a lower pKa, the reaction is of unfavorable equilibrium and therefore will not proceed.